Welcome to my YouTube channel. In this video lecture, I am going to solve the next 10 questions, questions 11 to 20 from Great Circle chapters in 𝐃𝐞𝐻 book. So let's start with question number 11. Aircraft is at position 60 north 5 west, tracks 090 for 315 km. On completion of the flight, what will be the final position? So this is your Earth. This is your Earth representation. Okay. Here is your prime meridian 0 degree. Your position is at 60 north 5 degree west. 60 north 5 degree west. And you are tracking 090. That means you are traveling in easterly direction for a distance of 315 km. So what will be your final longitude or final position? Now since you are traveling easterly direction, the destination latitude, the latitude of the destination will be the same. That will be 60 degree north. 60 degree north. What will change is the longitude. So since you are traveling easterly direction, you are flying a rumline track. So let's employ the rumline distance formula. Rumline distance equals to d long in minutes into cos lat. So here rumline distance is 315 kilometer. So 315 divided by 1.85, 170 nautical miles. So 170 nautical miles equals to d long in minutes into cos of 60. Same latitude, so cos 60. So d long in minutes equals to 170 divided by cos 60. So 170 divided by cos 60 is 340 minutes. 340 minutes divided by 60 is 5 degree 40 minutes. That means your new longitude is 5 degree 40 minutes to the east of your initial longitude. To the east of your initial longitude. Your initial longitude is 5 degree west. Now the d long between prime meridian and this 5 degree west longitude is 5 degree. What is the d long that we got? 5 degree 40 minutes. So it's more than 5 degree by 40 minutes. So additional 40 minutes. So additional 40 minutes d long will fall in the eastern hemisphere. So our destination will be in the eastern hemisphere, and the longitude will be 40 minutes east longitude. 0 degree 40 minutes east longitude. Next. The autopilot of aircraft is coupled to the inertial navigation system, and you are traveling from waypoint 1 60 north 40 west to the next waypoint, which is at same latitude but different longitude 30 west. What is the latitude of aircraft? Latitude on passing 35 degree west. On passing 35 degree west. So you are in the north hemisphere, so the great circle will pass through the nearest north pole. Alpha, Bravo. So alpha is 60 north 40 west, and Bravo is 60 north 30 west. 30 will be to the east of 40. Okay, so plot correctly. 60 north 60. What is the approximate latitude of aircraft on passing 35 minutes west longitude? Now 35 minutes west longitude will be between 30 degree west and 40 degree west longitude. So 35 west longitude will be somewhere here. We have to find the latitude of this longitude. Latitude of the position. We have to find the latitude. You have to find aircraft position at this particular latitude. So we know the longitude 35 west. The latitude will be more than more than 60 degree north. It will be more than 60 degree north. By what amount? that we have to find out. So let's now step 1, make a triangle. Step 1, make a triangle like this. Okay, this is the triangle that we have made. Now, what is the distance between A and B? The distance between A and B is departure. Departure. Okay. So what will, if this total A and B is departure distance, run line distance, this will be equal to half of departure. Half of departure from here to here. Half of departure, right? Okay. Next. What will be this? This will be a complete conversion angle. This conversion angle, same here, conversion angle. Okay. So now we have drawn a line through that conversion angle. So that conversion angle will get divided into two parts. Will get divided into two parts. One part outside the triangle, this one, and another part inside the triangle. We are concerned about the part of the conversion angle which falls in the triangle. So ignore this outside one. Okay, so this angle will be half of convergency angle. Whatever convergency angle you find, divided by 2. Okay, so now we have a triangle, we have a proper triangle. So let's first find step 1, draw this diagram, understand this. Step 2, find departure, then divide that departure by 2. So departure, your line distance is d long into cos of lat. So d long in terms of minutes, 40 west, 30 west. Okay, 40 west, 30 west is 10 degree into 60, convert that into minutes, into cos of latitude. Both are at same latitude, 60 north. So 600 divide by 2, that is 300 nautical miles. So half of that will be, half of departure will be half of 300, that is 150 nautical miles. Okay, so we have got this value 150 nautical miles. Step 2, conversion angle. Step 2, conversion angle, which is half of convergency. So d log in degrees into sine of lat. So again, d log is 10 degree, sine of 60. So convergency is sine 60 to 10, 8.88 degree 39 minutes. So convergency angle will be half of that, 4 degree 19 minutes, and half of convergency angle again will be again half of that, 2 degree 9 minutes. Degree 9 minutes. So approximately 2 degree. Fine. So 2 degree. Now next step. Next step will be to apply tan theta formula in this triangle. So we have this, we will have to find this x value. This x value is nothing but great circle distance. This meridian of longitude is a great circle track. So a part of that longitude will be a great circle track. We are going to calculate the distance traveling from this particular latitude 60 north to this particular latitude. We have to find this latitude. We will find that out first. Let's find the distance between them. So step 3, next step whatever is tan theta opposite side upon adjacent side. So tan of theta, here theta is equal to tan of half of convergency angle, which is 2 degree. So tan 2 degree, opposite side. Opposite side is this x great circle distance, divided by adjacent side, which is half of departure 150 miles. So great circle distance is 150 nautical miles multiplied by tan of 2. So tan 2 into 150 is 5.2 nautical mile, of approximately 5 nautical mile. That is your great circle distance, 5.2. Now we know that the definition, 1 minute of latitude, 1 minute of latitude equals to 1 nautical mile. So 5.2 nautical mile or approximately 5 nautical mile will be equal to 5 minutes of latitude, will be equal to 5 minutes of latitude, right? So the difference between this initial latitude and your final latitude is 5 minutes. Very small difference, 5 minutes. Okay. So initial latitude is 60 north. So your final latitude, destination latitude will be, the top will be 60 north plus 5 minutes. So 60 degree, 5 minutes north latitude. Simple. So this is your answer. A Lambert's chart has a constant of cone point 0.8. Straight line drawn on this chart from 53 north 4 west towards destination is 080, and the great circle track at destination is 09 or 2. So great circle track at A 080, where it goes to B, or when it reaches B, it becomes 09 or 2. What is the longitude of B? Now we all know that the difference between two great circle tracks is equal to convergence. So here the difference between 80 and 92 is 12 degrees. So convergence equals to 12 degrees. What is convergence? D long in degrees into sine lat. Now here they have used the term constant of the cone. Constant of the cone is another terminology for sine of latitude. So instead of saying sine latitude, they have used the word or used the term constant of the cone. So 12 degree divided by constant of cone or divided by sine latitude, which is 0.8 given in the question, is equal to d long in terms of degree. So 12 by zero point 0.8, 15, 15 degree. So the d long between these two positions is 15 degree. Now check the positions. Alpha is 4 degree west. Going towards a destination, you're flying a direction of northeast. That means Bravo, your destination is to the east of A. So let's draw that. A is here, B is here. You're flying A to B in the direction of 080. Position A, 4 degree west. Position B will be 15 degree different from position A. So 15 degree to the east of 4 degree west. Now, next to 4 degree west, there will be a prime meridian 0 degree, right? 4 degree west, 3 degree west, 2 degree west, 1 degree west, 0 degree meridian. Then 1 degree east, 2 east, 3, so on and so forth. So here the total difference is 15 degree. So 15 degree will be divided into two parts. 15 minus this 4 degree and another 11 degree in the eastern hemisphere. So the position, the longitudinal position of Bravo will be 11 degree east. 11 degree east. From prime meridian 11 degree to the east. So 11 east. 14. You are flying with the aid of an INS system. So waypoints. Waypoint 1, waypoint 2 is given. When passing 025 degree west, what will be the latitude? So similar to the previous question, okay? So step 1, let's draw this. So A, 60 north 30 west, 60 north 20 west, same latitude, okay? And you have to find the latitude where this aircraft will be flying, okay? Longitude is 025 west. You have to find this particular latitude. Okay, aircraft, the latitude where aircraft will reach the peak of its great circle track. and then fly towards Bravo. They will be joined by a rumline track. So the distance between them will be called departure, rumline distance, right? And the angular difference between this great circle track and this rumline track is called convergency angle. Now your next step will be to draw a triangle here, this triangle. Now the angle inside this triangle will be nothing but half of convergency angle, right? So the convergency angle is here. Similarly, this convergency angle will be on this side of the triangle also. And that complete big convergency angle has got divided into two parts. One part, one part outside the triangle and one part inside the triangle. So we are concerned about the part inside the triangle, which will be half of convergency angle, because this side of the triangle will be bisecting that angle, okay, dividing that angle into half. Next, what will be the measurement of this side of the triangle? It will be half of departure. Why half? Because 25-degree west is in the center position from 20-degree west as well as from 30 west. So this side of the triangle will be equal to half of departure. Now step 1, calculate departure, which is your rumline distance, d long in minutes into cos of latitude. So d long, 10 degrees multiplied by 60 minutes, cos 60, 300 nautical miles, cos 600, cos 60 is half. Now half of this rumline distance will be equal to 300 by 2, 150 nautical miles. So this side of the triangle is 150. Now next step, convergency. D long in degrees into sine lat. 10 degree into sine 60, 8 degree 39 minutes. Convergency angle, half of that, 4 degree 19 minutes. Half of convergency angle again, so divide again by half, 2 degree 9 minutes. Okay, so 2 degree 9 minutes. Now let's apply trigonometry here. So tan theta is opposite upon adjacent. So tan theta here, tan of 2 degree 9 minutes, so approximately 2 degree. Okay, so tan of 2 degree will be opposite side, which is your this opposite side. This is nothing but your great circle distance divided by 150 miles. So great circle distance is 150 tan 2. 5.2 nautical miles, or approximately 5 nautical miles. So this distance is 5 nautical miles. यहाँ से यहाँ तक. Now we know by definition 1 minute 1 minute latitude equals to 1 nautical mile. So 5 nautical miles will be equal to 5 minutes of latitude. So that is the difference. D lat is 5 minutes, very small. Initial latitude is 60 degree north, and the D lat difference between this latitude and final latitude is 5 minutes. So the new latitude will be 60 degree 5 minutes north. 60 degree 5 minutes north. Okay, so that is your answer. Next. Departure between two points is 900 miles. What is the longitude? So again, departure is your rumline distance, d long in minutes into cos lat. So 900 equals to d long into cos latitude cos 60. D long in minutes. 900 by cos 60, 1800 minutes divided by 60, 30 degrees. So point A is 160 east. So let's draw this Rumline diagram. Rumline diagram is draw the earth with respect from the perspective of the North Pole. So north, prime meridian, 180 east, 180 west, 90 east, 90 west. So your initial position is 60 north, 160 east. 160 east यहाँ पे होगा. D long is 30 degree. That means your final longitude can be to the east of 160 east or west of 160 east. Westerly directions are clockwise. So 160 east, 160 east is your initial longitude. D long is 30 degree. So your final destination, if you fly a westerly direction, will be 160 minus 30, that is 130 east longitude. If you travel in the easterly directions are anti-clockwise. So that means if you travel easterly direction like this, your new longitude will be 160 east plus 30 degree. Okay, so 160 east plus 30 degree is 190, but the maximum value is 180. So extra 10 degree, 190 minus 180 is 10 degree. So extra 10 degree will be covered or traveled in the western hemisphere. So your longitude will be 170 west. 170 west. So either 130 east is your destination or 170 west. So pay attention to the direction of your journey in your given in your question. If it's westerly, it will be 130 east. If it's west easterly, it will be that 170 west. Okay. Next, you're traveling from waypoint 1 से लेके waypoint 2 से लेके waypoint 3. Three waypoints are given. All three are at same latitude. 30 west, 20 west, 10 west. What is the track change when you pass waypoint 2? So let's draw this. 60 north, 30 west, 20 west, 10 west. Since you are in the north hemisphere, the great circle track will pass to the nearest north pole like this, then like this. Now they have asked us to find the change in the great circle direction at waypoint number 2. This is your initial waypoint 1, waypoint 2, waypoint 3. Okay. So the change in great circle direction between initial and final points equal to convergency is equal to convergency. Okay. So let's find convergency here. So here the convergency is d lat correction d long between the longitudes is d long in degree to sine 60. 10 into sine 60 is 8.8 degree 39 minutes or approximately 9 degree. So what will happen? You're traveling from 60 north, 60 north, 30 west से लेके 20 west. So that means you are in the northern hemisphere. We all know this DIID diagram, which says if you are in the north hemisphere and you travel in the direction of east, there will be a great circle direction increase. If you travel west in the northern hemisphere, the direction of great circle will decrease. So we are in the north hemisphere and we are traveling 30 west से लेके 20 west easterly. So the direction, the change of great circle direction will be an increment, an increasing one. So the increase will be equal to 8 degree. So what is the approximate track change on passing waypoint number 2? The track changes or track increases by 8 degree 39 minutes over waypoint number 2, 17. Aircraft autopilot is coupled to waypoint 1 से लेके waypoint 2, 50 west, 40 west. What is the approximate latitude of aircraft on passing 45 west? Again, draw this diagram. Okay. So A, B, traveling from 60 north 50 west, 50 west. The longitude concerned here is 45 west. So 45 west is in the center, between exactly between 40 west and 50 west. Draw a triangle like this. Then this will be equal to your departure line distance A and B, since both are on the same latitude. All latitudes are lines. So this distance will be half of departure. This angle will be half of convergency angle. This entire thing will be convergency angle. We have drawn this side of the triangle and this side bisects the convergency angle in two parts. This half and the outside another half angle. Now step 1, find departure. Departure equals to d long in minutes into cos of latitude. So d long is 10 degree into 60 into cos 60. So that is equal to 300 nautical miles. Half of departure will be half of 300, that is equal to 150 nautical miles. Convergency, d long in degrees into sine latitude. So 10 degree into sine 60. 8 degree 39 minutes. So convergency angle, half of convergency, so half of this 4 degree 19 minutes. Half of convergency angle 4 degree 19 minutes का भी half 2 degree 9 minutes. Okay, so this is 150 this side. This angle is 2 degree approximately. We have to find this great circle distance. Apply tan theta. Tan 2 degree. Opposite side, which is great circle side. Distance 150 miles. So great circle distance will be 150 multiplied by tan 2. 2 into, so tan 2 into 150. 5.2 nautical miles. Now we know that 1 minute of latitude is 1 nautical mile. So approximately 5 nautical miles of distance will be equal to 5 minutes of latitude. So d lat. So if this is 5 nautical miles, so 5 nautical miles is equal to 5 minutes. So you are traveling from 60 degree north upwards in the northerly direction. So 60 north plus 5 minutes. This latitude will be 60 degree 5 minutes north. Okay. Next. Departure is given. What is longitude? So Ramline distance is d long in minutes into cos of latitude. So 1200 cos 60, 2400 minutes या फिर 40 डिग्री. ठीक है. So 1200 divided by cos 60, 40 degree. Now 60 north, 160 east. Draw the Ramline for diagram. This is your north pole, 0 degree. 90 east, 90 west. 160 east is your initial latitude, longitude. Now if you travel westerly directions are clockwise. So westerly directions will be clockwise. So your final destination longitude will be to the west of 160 east. So you will have to subtract 160 minus d long 40, which is 160 minus 40 is 120 east. If you choose to travel easterly direction, the destination will be to the east of 160 east. So 160 plus 40 is 200, right? We do not have 200. The maximum value here is 180. So extra 20 will be traveled in the western hemisphere. So 180 minus 20 is 160. So your destination is 160 west. So there are two possibilities. It can be either 120 east or 160 west, depending on what direction you take. Departure between two positions 1800 nautical mile. What is the longitude? So similar question, departure is d long in minutes into cos of lat. So 1800 equals to d long in minutes into cos of 60. So d long in minutes equals to 1800 cos 60 degrees. Okay. Initial longitude is 60 east. You are traveling easterly direction. So North Pole, prime meridian, 180 east, 180 west, 90 east, 90 west. 60 east. 60 east कहाँ पे होगा? Somewhere here. Easterly directions are anti-clockwise. Okay. Easterly directions are anti-clockwise. So what is D long? It is 60 degree. So if initial longitude is 60 east, final longitude will be somewhere on this side, to the east of 60 east. So 60 plus 60 is 120. So your destination will be 120 east. Aircraft, aircraft with its autopilot connected to its inertial system flies from point A, which is at 45 south 10 west, to point B 45 south 30 west. What is the course of aircraft when it arrives or goes to B? So we have to find great circle track at A, great circle track at B. South hemisphere, so great circle will be like this. Since both are located at same latitude, A and B, great circle Rumline track B to A will be 270. Considering this is your north hemisphere, south hemisphere. So great circle B to A will be Rumline B to A minus convergency angle. Okay, Rumline B to A is this big value. So great circle B to A will be only this much. So it will be this big value minus this small part which is the convergency angle. So what is convergency here? D long. So 30 west minus 20 west is 20 degrees into sine of latitude, sine 45. So 20 to sine 45 is 14 degrees. So convergency angle is 7 degrees. So great circle B to A will be 270 minus 7, that is 263. Great circle at A will be, so the difference between two great circle tracks is equal to convergency, right? Now we are in the south hemisphere and B to A we will be traveling westerly. So DIID formula. In the south hemisphere traveling westerly, great circle will increase. So great circle at A will be great circle at B plus convergency. So 263 plus 14, that is 277. Okay. So 263 great circle at B, 277 great circle at A. Simple. So this is how you do all these 10 questions. Okay. Very lengthy solutions of every question. So it takes a lot of energy. So make sure you divide these lessons in parts. Do first 20 questions in morning, next 10 questions in the afternoon, next 10 questions evening, next 10 questions in the night. So divide this chapter in different parts and solve 10 questions in during different times of the day. If you have any questions, doubts, let me know in the comment box. And I request you all to share this video lecture with your friends who are also preparing for the exam. Hit the like button if you have liked this video lecture and subscribe if you haven't yet. See you.